Hi, Calculus. We are to 2.4, which is exponential this time. And it's going to move just like our other graphs, except now you have to figure out what the parent graph is before we move it. And then we're going to work with exponents and when they have to have like bases and how to solve those. And then we'll talk about compound interest and continuous interest. All of some of my favorite things. So I hope you're doing great. So get your notes out and let's move. Okay, when you look here, we're going to translate, like I said, and then we're going to do, if I could get to my graph, there we go. So translation, like basis, compound interest, and continuous interest. So now the first one is like basis and translations of exponential functions. The first part to know is what your parent graph actually is when you're here. So you take out the numbers, so the 2 and the 4, and the parent graph is actually 3 to the x. So you need to graph that. When you get good at that, I do not expect you to do a table anymore, but right now I think it might be a little new. So let's do 3 to the x, and we're going to graph this, and then we're going to move it like we've done before. So let's get going. So if we do, let's just do our straight -2, -1, 0, 1, 2. Okay, when you plug in -2, that's 3 to the -2, which is 1/9. Remember, it moves it to the denominator. 3 to the -1st is 1/3. 3 to the 0, 1. 3 to the 1st is 3, and 3 squared is 9. Now, when you look at this, our negatives, no matter how negative they get, they will never get to 0. So I know we have a horizontal asymptote at 0. Now let's graph these graphs. So -2 is 1/9, 1/3, 1, 3, and 9. So this is my parent graph that we're going to graph here. Now I need to move my parent graph. So when you look at the move, we're going to look at our x's just like always, and x plus 2 is attached. So you do just like before. X plus 2 equals 0. So x equals -2. So I am going to go left 2. The -4, just like before, means down 4. So I'm also going to go down 4 from the -4. All right, so the first thing I'm going to move is my asymptote, because I know he's going to go down to -4, and that's going to help me get my graph right. So now we're going to go here. I know it goes down 4, which is close to the asymptote, and left 2, and I put my new dot. This one here, again, down 4, left 2. Here 1, down 4, left 2, and you're just moving all of them down 4, left 2. And then again, down 4, left 2. And draw in your transformation. And you're done. Okay, I hope you did well. It's your turn. Pause and give it a shot. So your parent graph should have been. Now, I use the -2x. I understand that that's actually a reflection, but sometimes it makes the move better, or easier, I should say. So let's go to the -2x. -2, -1, 0, 1, and 2. So we're doing -2 to the -2. What I want you to understand is this exponent is only to the base of 2. So this negative does not go away. So this moves it down, but it stays negative, so it's -1/4. The same with this one, so it's -2 to the -1st. So this 1/2 is now negative. -1/2, and then you get, again, -2 to the 0. Well, that's 1, but that's still -1. I think you got the point here. So -1, -2, -4. So again, my asymptote is going to go here. It's not going to get 0, but this time it's going to approach from the bottom. So we go to -2, -1/4, -1/2, -1. 1 is -2, and 2 is -4. And draw in your parent graph. There we go. Okay, now how is my parent? How did you move your parent graph? So you should have looked up here and said, oh, it's x plus 1. So that means x equals -1. I'm going to move left 1. Up 3, because this is a +3, and I'm going to go up 3. First thing, I'm going to move my asymptote. So he's up 3. So now every point goes up 3, left 1. This point, up 3, left 1. Up 3, left 1. Again, up 3, left 1, and up 3, left 1. Draw in your transformation. I hope you did well. Okay, now we're going to go on to like bases. And what you have to do here is you have to get the bases the same. And you should know, like if I gave you 5 squared and said that equals 5 to the x, you know x equals 2. Because once the bases are the same, the exponents are equal. So I go down here and I have a 3 and a 9. Well, 3 is okay because he's prime. But I need 9 into the terms of 3, which means that has to become 3 squared. So we're going to rewrite this 3 to the 3x equals 3 squared x plus 1. Well, now the bases are the same, so the exponents have to be equal. So we just do 3x equals 2x plus 2, because I'm going to do that distribution. Subtract your x, or your 2x, and x equals 2, and you're done. Okay, I have a typo here. Make this here 128, and life should go better. All right, pause and do yours. So 32 should have been 2 to the 5th times 2x minus 1, and 128 should have been 2 to the 7th times x plus 3. All right, bases are the same, so let's just write this one out. So we have 5 to the 2x minus 1 equals 7 times x plus 3. Do your distribution. I'm out of room here. So 10x minus 5 equals 7x plus 21. Okay, let's subtract the 7. I'm going to move up here. And we're going to get 3x equals, add the 5. So x equals 26 thirds. And you are done. All right, now we get to talk about money and how money works and how you want to invest and those kind of fun things. All right, there's a couple of formulas. There's actually 3. This one here is just simple interest. Interest equals principal times rate times time. It's almost always annually. There's nothing real fun about this. And it's also how your money grows the least. This one here is compound. So that means I get interest more times a year. So the more times I put my interest in, then my interest starts earning interest, which is what we like. All right, P is principal, R is rate, N is how many times it's compounded, T is how long you leave it in, how many years. And then your third one is continuous interest, which is nice but not often, are not offered often, and it really doesn't make a ton of difference. So we get principal, E is just the E on your calculator, right? R is your interest rate, and T is your time. Okay, let's see how to use these things. Here we go. We're going to invest $9,000. Okay, so that's my principal. I need to write that down. So principal equals $9,000. Add a 6% interest rate. So I know my R is, I'm going to put it in decimal form already. Compounded semi-annually. Compounded, so that's N. Semi-annually means 2 and for 4 years. All right, since I have a compounded annually, or semi-annual, I know I have to use my compound interest formula, which is P1 plus R over N to the NTR. That's N times 2. Can't write today. To the NT power. Okay, let's plug our numbers in and see how we do. So we go here, we're going to do A equals 9,000 times 1 plus 0.06 divided by 2, all to the NT, so 2 times how many years? 4 years. Oh, I am in the wrong spot, aren't I? Okay, we're going to do this 8 years underneath here. Okay, we type this into your calculator, just as is. You don't have to do anything special. And you should have got your interest rate to be, get the calculator out. Give me a second. 11,493. 11,400, and I got 93 cents. All right, now let's do the same thing with my 8 years, since I wrote this in the wrong spot. So nothing changes except the 4 in the formula, 2 and 8. So now we get A equals 9,000, 1 plus, okay, Me and this thing are not getting along today. 1 plus, still the same interest rate, still compounded semi-annually, still, so the end's the same, and this time I put in an 8. And when you put that in your calculator, you should get $14,442.36. All right, so if you've noticed, there's not a ton of difference between semi-annually and compounded continuously. Roughly $40, right? But it's still my $40 and not their $40, which is what we like. 60% annually, which is compounded for 4 years. Okay, so now we want to do the same thing. She found a different bake and it compounds continuously. So this in here was 8 years. So between, oh, I am so sorry. I said this wrong. So we got 11,400 up here to 14,000 here. So she got almost $3,000 different, right? Just by leaving it in for 8 years, which is awesome. My fault. Okay, so now let's do compounded continuously. So we go here, continuous formula. We know that's A equals PERT. Okay, we do the same thing before. Nothing's changed. She still had $9,000 to invest. She still is earning 6%, and she is still leaving it in for 4 years. So let's type all this in. So how much money will she make? So we're looking at continuous versus our compounded semi-annually. So we plug this into our formula. We get 9,000 e to the RT. So this is 0.06 times 4. A little different than our other one. It's not the NT this time. Okay, type that into your calculator and you get $11,441.24. This is where she only earned about $40 more. So these two are not a ton different. Sorry about that. Okay. Which bank is different? Of course, the continuous one. And she earned, I think it's close, what is it, $40.31, something on that order. Check my math. If I'm wrong, fix it. Okay, here we go. All right, if you look at this graph and you plugged it into and you started to graph them. So I'm going to let this be 0, 1.75. So this guy's 10, right? I'm just counting up by 10. So I'm going to let this be my initial and we're going to keep going. So 30, 40, 50, 60, 70, 80. So in other words, 2000 is actually 70 on my graph. 80 is actually 2010. So that's where this 80 came from. And you look at the graph, it goes up like so. It is definitely not linear. It's an exponential graph. So since it's an exponential graph, I know I have to use an exponential formula. All right, so your exponential formulas are PT, where you're at, your initial value, A to the T power. Okay, so A is the rate of increase or decrease, T is how much time. So when we go here, at the beginning, so my very first point is 0, 1.757. I have to create the formula for this graph. So in order to do that, I need 2 points, and I need to know that it's exponential, so I'm plugging it into this form. So the first point I chose was my initial, because this is my initial value. The second point, you can choose anything. I just chose the last one, which is 80, 12.447. Okay, I know this is where I'm ending up, so that's my 12.447. And I know it took me 80 years to get there because 80 is where my graph is at. So now we use those numbers and we plug them in here and we solve. So we divide by 1.757 and we get 7.08 equals A to the 80th. I need to get rid of the 80th. So I need to take this, if you remember, times the 1 over 80 power, right? Because that equals 1. But then I also have to do this. So I'm going to take this to the 1 over 80 power. and I'm going to get 1.025. So A is 1.025. Now I have to make this equation. So that means my initial is not going to change. So where I'm going to go is equal to my initial times 1.025 to the t power, whatever time is. So now when I say, well, could corn production be doubled what it was in 2010? Well, 2010, I know it was 12.447. So I need to double that. So I'm going to take 12.447 times 2. So we're doing this. I needed more room here, huh? So we're going to take 2 times 12.447 because I'm going to double it. I want to know, I'm going to still have my same initial, 757. I'm plugging into this formula right here, times 1.025 to the t, because that's what I want to find. So I'm going to divide by 1.757. I should multiply this out first, which is 24.894. Divide that. I'm going to go down here. So now I got 1.025 t equals 14.168. Well, how do I get this t out of this exponent? This is an issue, right? That's why we need logs, and that's the next section or tomorrow's notes. So good luck on your homework, and then we'll figure out how to solve this next time. Thank you.